David and his brother are playing with Lego bricks, which can be approximated as rectangular prisms with a volume of 5 cubic centimeters each. Their mother tells them to put their blocks away into the cylindrical carrying case, which has a radius of 5.73 centimeters and a height of 30 centimeters. As David and his brother are putting away the blocks, they count to see how many they can fit in the case. They find they can fit a maximum of 445 blocks in the case. Explain to David why this result is unexpected and why he cannot fit additional blocks into his case. Great, guys. So do two things. Take down any key information you see in this problem and come up with a plan for how you're going to solve this out. Hit play once you got your answer. Alrighty, so just taking a look, our radius 5.73 and height of 30 centimeters for the carrying case. We also have a volume of 5 cubic centimeters each for the Lego blocks. And then lastly, we've got this maximum of 445 blocks that end up fitting in the case. We want to figure out why that number is unexpected. All right. So our plan to do that is to find the volume of the cylinder, find the number of blocks that should fit in the case according to our calculations, and then explain the difference between the answer we get and that maximum 445 blocks we get there. All right, so go ahead, hit pause, and calculate out the volume of the cylinder first. Hit play once you're done. Alrighty, so volume of our cylinder. Error I've seen a lot is folks forgetting to multiply by pi. So here I did pi times the radius, which is 5.73 centimeters squared, times 30 centimeters. That gave me the volume of 3,094.43 centimeters cubed. All right, next step, find the number of blocks. All right, so to do that, what we'll do, and this we'll definitely see this a lot, is you'll take your number of you'll take the volume of the cylinder or whatever thing you're trying to fit the objects into, in this case our cylinder, and then divide that by the volume of the Lego brick or whatever it is you're trying to fit into that object. So we already got our volume up here at 3,094.43, all right, centimeters cubed, and then we're going to divide that by the volume of the Lego brick, which from up here was 5 centimeters cubed there. Divide those two things and we get 618.88, which will round down to 618 bricks because we can't have 8/10 of a brick. All right, so now I want you guys to think about, why is this answer, which we calculated correctly using our volume formulas, using the correct equations, why is this answer different from the 445 blocks David and his brother counted? Hit pause, take 30 seconds, then hit play once you got your answer. Alrighty, so they only fit 445 blocks because the blocks are rectangular and the case is a cylinder. So there would be lots of unfilled space. If we have a cylinder, something like this, right, and we have some rectangles in it, they're going to have some unused space that's going to fill into this shape, right? We're going to have all kinds of unused space in that cylinder because the rectangles won't fit exactly in a circle. So that is our answer, why this answer is unexpected. Okay? So let's think now, what is going to be true about volume or surface area problems like this one in real life for our key point? Hit pause and then hit play once you've got your answer. So what we're going to see in real life volume or surface area problems is that surface area and volume equations represent ideal situations and may not accurately represent real life situations. So just in this case, by our calculation, we thought we could fit 618 of those Lego blocks in there. However, because they're different shapes, rectangle Lego blocks in a cylindrical carrying case, there's going to be empty space, little nooks and crannies that we can't squeeze those Lego blocks into. So we got all that empty and unused space. So we're going to test out this idea with a couple of problems here. All right, first one up. We've got these tennis balls that are tightly packed into a canister. What is the relationship between the volume of the tennis balls and the volume of the container. All right, go ahead and hit pause, then hit play once you got your answer. So, and ding, 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 our answer is going to be B. The volume of the tennis balls is less than the volume of the container. We can see right in this picture, there's this empty space in these pockets here where those tennis balls don't go right up to the edge of the canister. Right? So in each of those spots, that is unused volume, just showing us that the volume of those tennis balls is less than the volume of that whole container. All right. Now, clearly, they're not going to be greater than the volume of the container because they're not bursting outside of the container as well. All right. Question number 2. Single MTA R160 subway car has a volume of 7,135 feet cubed, and people on average have a volume of 2.2 feet cubed. How many people will fit in one subway car? All right. So take 30 seconds and hit play once you've got your answer. All right, so looking at this, there are 2 answers that I can get rid of right away, right? So choice A, we're never going to fit 15,000 people into one single subway car. That would be crazy, all right? And same thing, 10, you can clearly fit way more than 10 people into a subway car. So that just leaves us with B, C, and D, all right? So I'll just check if that number is correct. So I'll take the total over here and then divide it by the volume of average volume of one person, and I will get 3,243. But let's just stop and think about a subway car, right? Is all of the space in a subway car just unused space that we could fill with people? No, right? It's clearly not. There's poles in the way, there's benches in the way, there's the doors, it's all kinds of different things. And furthermore, just like a tennis ball or a Lego brick, people, you can't just stack them up on top of each other. They're not all the same size and whatever. So there's going to be wasted space. It's not going to be anywhere close to 3,243 people, right? There's going to be way more space that there's going to be way more space that's going to get unused, so there'll be way less people. And actually, a subway car usually only holds somewhere around 200 people or 250 people, right? So there we go, guys.